dari sana sini ya, dari sana sini. Jadi pas ada shoot stay tadi liatin kondisinya harus lihat pas game udah mulai bangun itu kan turun ke tengah shoot dari menaik.
Oke. Selamat siang Bapak Ibu.
Selamat siang.
Cerah sekali. Gimana makan siangnya, enak ya? Alhamdulillah. Oke, Bapak Ibu, ini kalau tadi kita udah lunch, udah makan siang, udah sholat, udah istirahat, saatnya kita kembali. Tapi sebelum kita kembali, ada baiknya saya mau bikin penyegaran dulu. Kan tadi dari dulu ya depan ini banget postingan nih biar fokus sebelum ke acara yang selanjutnya. Saya punya sedikit penyegaran. Ini biasanya saya pakai bermain sama anak saya kalau dia mau tidur. Jangan habis ini tidur biasanya. Jadi permainannya namanya follow the move. Follow the move. Ini biasanya kita tahu patternnya dari zaman Benyamin masih muda sampai sekarang Prabowo jadi presiden, ini kita tahu semua. Saya bikin 4 gerakan aja, cukup 4 gerakan. Kalau namanya follow the move berarti kita melihat gerakan yang saya peragakan, jadi harus diikuti. Pertama ada pegang kepala, nah, lalu pundak, nah, lalu telinga, iya, lalu hidung. Ih bener, itu zaman saya ya. Ikutin bro. Oke, jadi saya lakuin dikit. Kepala,
Lupa
ya,
dia.
bukan. Oke, kepala, pundak, hidung, salah ya? Salah, kepala, pundak, telinga, hidung, kepala, pundak, telinga, hidung. Udah ya? Oke, kalau udah fokus nih kita coba ya. Bismillah dulu. Jangan follow. Oke. Just follow
The move.
just to follow my move.
Inggris Pak.
Ya. Ya. Kepala, pundak, telinga, hidung, kepala, pundak, telinga, hidung, kepala, telinga. Saya tahu. First one, pundak apa tuh? Boleh. Pundak. Ya. Repeat. Fokus nih, seru banget. Oke, kepala, pundak, telinga, hidung, kepala, pundak, telinga, hidung, kepala, kan follow the move nih. Sekali lagi dah, berfokus. Kepala, pundak, telinga, hidung, kepala, pundak, telinga, hidung, kepala. Oke, karena sudah fokus, saya mau pantun. Lupa saya belum pantun hari ini. Oke, bolu kukus enak, bikin lagi.
Cakep.
Iya. Lupa. Biasanya mau ngomong bahasa Inggris tapi lupa ya bahasa apa. Pantun, here pantun means joking. Joking to no, for
Panik gitu.
Oke. Ulangi lah ya. Bolu kukus enak bikin lagi.
Cakep.
Karena kita udah fokus, ini kita lanjut acara lagi.
after the break and the list of jokings and whatever warm-up you got here, I don't remember what you're saying, but I remember the sequence, right? Let's continue, and according to the schedule that we've got, we're going to show you a few information about the pipettes calibration. You are saying pipettes or pipettes? Pipettes, okay, I try to memorize. Pipettes calibration. So here I start from the presentation which is speaking about the multi-channel pipettes and pipettes calibration. And multi-channel pipettes calibration today is a main topic for every laboratory who is doing the calibrations of pipettes because of the change of ISO. For those who are following the calibration of pipettes, not so, I mean, that's not yesterday, not months ago, a little bit longer ago, the ISO changed. So ISO 8655 in 2022 already changed, and that part which is responsible for devices, as far as I remember, is the sixth one. They improve a little bit more the information. They also change the way how we can calibrate multi-channel pipettes, right? Years ago, everybody was doing the same job, which means when we do have 8 or 12 channel pipettes, we did the calibration channel after channel, correct? When you're doing again that, still means yes. Okay. So, channel after channel, which means we do have 8 or 12 separate single channel piston pipettes, and that job usually took you how much time? 7 hours, 8 hours, or less for one single option. So 12 channel pipette, right? 7, 6, 8 hours, 8? 8, so 1 day. 1 day, one single pipette, right? And that ISO changed that. So the 2022 version changed that, and they said that you need to use multi-pen weighing device, right? In background, it was already mentioned on the first presentation, in background we've got our automatic device for that. And right now we do have only one solution in such a construction on the market, which gives you the chance to be compliant with the ISO. So basically we are not anymore, we are not able to calibrate the multi-channel pipette one after another. We need to dispense the liquid from all of them. I'm speaking about all of the channels of the pipette. So, shortly, let's see that in presentation about AP12, because AP12, this is exactly that device dedicated for the multi-channel pipette calibration. As you see, who is the customer? Who is that one? I just lost the English word. Who is what kind of department or institution who is requiring such of devices? All of them actually, which are going to be which are going to calibrate or follow the ISO standards. So every accredited laboratory, every of the laboratory from the private sector, which is according to ISO, either verifying or calibrating the pipettes. Then, what do you gain when you've got such a device that we offer considering multi-channel pipettes? First of all, time. Obviously, time is money, right? Here you do have the information that you can calibrate the pipette, that multi-channel, 12-channel pipette, around 1.5 hours. That was the very first device that we introduced. Right now, after improvements from the mechanical and as well software side, we reduced the time to 1 hour. So 1.5, not anymore, even 1 hour. From 7 or 8, like you said, right? 6, mentioned here, it was very, very experienced hand of the very, very fast Radwag employee. But as you already said, 8 hours, we're reducing to 1, thanks to that device. And I'm not speaking here about reducing the way of calibration, because still we speak about 12 channels. How many points we need to have according to ISO for the calibration? 1 point? 3 points when you speak about multi-channel variable? 10 measurements, but I'm speaking about the points of calibration. 3, perfect. 3 by 12 by 10. How many results? 360. 360 measurements you're going to do in 1 single hour. Imagine, because of that device. So how it looks like, how looks the whole system? This is what you're going to receive whenever you order AP12. AP12 that device that we mentioned, it has 5 decimal place. So we speak here about 0.01 milligram readability of the device. Our colleague mentioned on the first presentation that we do have 2 devices with 6 digits and with 5 digits. And here we speak about 5 digits. As you see, it is coming with the display, obviously, some mechanical side, which is the main module with the movable card, but it's also coming with a set of sensors. We do have here sensors which are monitoring ambient conditions, and we do have also the temperature sensor, which is monitoring the temperature of water, that one that we're using for calibration. All of them are calibrated. So the device is coming with a calibration certificate, and as well the ambient condition module that we call PHPS. It is coming also with the calibration certificate. So it's ready to operate. You just plug in, obviously install that according to the procedures, and you're ready to use. Use for calibration, which means whenever you test the pipette, and because of the databases that I already mentioned, it gives you the chance to finish the process with the calibration certificate. And that device is enough to finish the whole process without any PC software. Because we do have databases, and because our system will finish with a simple PDF, which is the calibration certificate. Not the report, not the result, the calibration certificate. So for those who are accredited in laboratory, you don't need to have any extra license or software on the computer, because that device will give you the result as a calibration certificate. As you see here, we do have the chance to operate with a single and multi-channel pipette. And here we do have 2 versions of devices. 5 decimal place with the readability 0.01 milligram, and that's AP12. And then we do have AP12.1, which has 6 decimal place. So we do have readability 1 microgram. That 1 microgram we develop exactly for that need, for single channel pipettes. What it gives you the chance to use that 12 channel solution. So the card, it has 12 vessels to calibrate single channel pipette by dispensing 1 by 1 measurement accordingly to the pipette itself. You can utilize 12 different of them. So after dispensing the liquid in that 12 positions, the device will move the card, just collect the measurements, that's it. So when you operate with 6 decimal place, single channel pipette, you speed up much more comparing to the regular microbalance, that one, that you've got as a manual, not automatic solution for single channel pipette. So don't forget that we do have here 5 and 6 decimal place, right? We do have here for that AP12 the dedicated card, which has something like we do have in the regular weighing chamber with the regular single channel solution, which is nothing else like a microbalance with this dedicated for the pipette's calibration kit. We do have here the construction of card, which looks like that it has evaporation trap under the cover, something that we do have here, and it was discussed by you, right, during the presentation, that we do have evaporation trap, and that helps us to reduce, obviously, the mistakes, or better to say, the uncertainty. We do have dedicated for the calibration of the system weighing pad. So either you disassemble that device, the card, just assembly back with the special weighing pad in the system, and you can calibrate that automatic device for pipette calibration as a regular balance. Or in the latest version, you don't need to even do that, because we do have special small adapter that you can place the mass standard directly on the kit or on that card, which is dedicated for the pipette's calibration. The system is also showing you the alerts whenever you are following or proceeding with the calibration. That first of all you need to check the level. Second of all, you need to check that the vessels are empty, because with the AP12 device you will get also the pump to basically take out the water from the vessels which is collected by dispensing the liquid. And also it will inform you about keeping the water in the evaporation trap. The system also, because because of that pump, as you see here, will reduce the daily process, daily routines. Because the pump, like here, as you see, it has either 4 or one single, I don't know how to say that, like a tube, to basically remove the water from the container during process of calibration. The system obviously is fully compliant with the latest version of ISO. What it means is compliant. It means that whenever you try to start the process, you basically add the pipette, you define that it is variable or fixed, you create the volume of the pipette, then the points for the testing, like I already mentioned, when you've got 3 points, usually when you speak about the variable pipette, what kind of points we need to choose according to ISO? The first point is, imagine we do have the pipette 10 microliters to 100 microliters, right? Very common, correct? First point for testing it will be, what kind of volume? 100, 1, 5, 10. The pipette, once again, the pipette is 10 to 100, right? The volumes that we need to test is a nominal, that's the first point, which will be 100. Then we do the 50% of the range, 50 microliters, and then 10% of nominal, which means minimum, which means 10, correct? So once you use our system and you choose that point, you automatically will be able to see the permissible errors, the criteria which is written in ISO. That means that the system is compliant with the standard, which is ISO. So whenever, first of all, you define the points for the pipette, it will give you the errors, the permissible errors according to ISO, and then the whole process will be recalculated after collecting the measurements accordingly to the permissible error. So the results will give you basically results which we are comparing. Sorry, the air conditioning is killing us here. Accordingly to ISO again. So you will have systematic and random error, and also Z factor calculated like written in ISO. Z factor, because obviously the system is monitoring ambient conditions, because we do have sensors, and it will ask you about the ambient conditions in the beginning and at the end of the process. The system also is compliant with the 21st CFR Part 11 for those who are already following the Code of Federal Regulation, which means it is giving you the chance to sign digitally the results, basically. Here we do have some details about 21st CFR Part 11, so I skip them because that's not a part of the presentation. And what else? Let's see how we are going to manage the processes when we do the calibration. So the system, the device, AP12, AP12.1 or AP12, it is giving you the chance to operate by using your smartphone, computer, or any other device which has Wi-Fi without the need of using software. As you see, we do have special application that we call Web Editor, which is nothing else like a website. So once you connect AP12 to your local network, or you connect your computer, your smartphone with AP12, according to the hotspot, the balance AP12 will open the website, which is giving you the chance to manage the data. So here you are able basically to add the user, because take a look. On the left side, you've got the access to users, customers, which are customers of your laboratory, pipettes, ambient conditions, and calibrations. So imagine I'm the laboratory that we call Radwag laboratory, and you are my customer. Let it be Intitech is my customer, right? So I will add to the database of customers Intitech, then I will define that Intitech, they do have 10 different pipettes. Fixed and variable, I will create them here. Then I link them with the customers, and that system gives me the chance to follow that data on the calibration certificate. So I need to do it only once, then I proceed with the calibration, which I create here in the calibrations database. And at the end, I've got very nice without the need of editing calibration certificate. So first we add the user which is the operator of the balance. Then I can create customer that will be my entity tag, and I can fulfill the data with the address, with the necessary data. I will add the pipet. As you see here, I can choose that is fixed or variable. I can create the name, the manufacturer of the pipet data. I will also able to create next calibration date, which is very useful for such a laboratories, because it will remind me automatically that when I add the date next year, the system will remind me before I need to call to them, to Intitech, and remind them, guys, the pipet requires calibration. Obviously, or maybe let's ask you, there is a required interval for calibration when we speak about pipet. So how often we need to recalibrate the pipet? Do we have an interval? Is it written interval, or we do have some regulation for that? Yes?
Yes, regulation.
Which one?
Comité Kalibrasi Nasional.
For Indonesia or generally? So you've got your local one.
Yes.
Because worldwide doesn't exist. System, which means standard, doesn't give you anything like that. If you do have some internal regulation for Indonesia, I'm fine with that. But generally, there is nothing like an interval in the system which gives you the need of recalibrating the pilot for any interval. We do have something that we call GLP, right? So good laboratory practice, which is giving you the common sense that I need to recalibrate whatever I'm using in laboratory with some intervals, right? We do have in our history, because we do have in Radwag something like a laboratory internal one, and also we do have the calibration center, which is doing such an activity, because Radwag, it has the laboratory which is accredited for the mass comparison, so actually calibrations and as well volume. And we do have customers in that volume calibration processes, which they sending pipettes every month. Because for them it's so necessary that every month they sending the pipette for calibration. Depends on the customer. But generally, if you're saying that in Indonesia you've got the period which is 1 year, here you can just add the reminder, and before the time will come, the system will show you, oh, I need to call to them and remind them, guys, the time is coming. Send the pipette to us or to anybody, because otherwise it's not valid, right? Then you do have, like I already mentioned, the ambient conditions database. So once you just open it, the web editor will show you historical data from the ambient conditions. So it's very useful, especially when you do have audit, right? If you are accredited in a laboratory, auditor will visit you, and auditor will question your ambient conditions. You can always prove them that my conditions are good, or they are just very fluctuating, but in the permissible area, which is written in the ISO, correct? So that's a very useful database, and the database is created by the sensors which we do have with the system. And then finally, you do have the calibrations. So once you proceed with the calibration, you will have also the results, which means reports. The web editor is showing you this is one of the tests that we create from 50 to 300 microliters, as you see, and it is going to show you for each channel, for each volume that we predefine at the beginning, the statistics, and as well all of the measurements with the masses and the recalculated volumes, the whole environment data as well. And this is what you will see once you finish the process, right? When we speak about the database, the whole database, on the list, you will already see by colors those reports which are negative, so those which finished as a prop one, those which are positive, and those which are in progress. It's not possible to show them how they're blinking, but they will blink also when they are in the process. And this is what you receive at the end. So finally, once you review the report, you create the calibration certificate, you will be able to see such a document. Obviously, it has a preview. here you do have the logo, which is Radwag logo, but you can edit that, you can customize that, so you can create your own. You can create actually whatever you require here. This is example. This is our standard template that you receive in the system, but obviously you can edit that because there is a designer dedicated for such of templates. And that's the full report. So as you see, that report was negative. Here you do have the measurements for each volume, so 300, 150, and 50 microliters, with the information about what kind of pipettes we got, pipette, who did it, for whom actually we was doing that calibration, and also you do have here in the summary the information about the ambient condition module, that one that we use for the whole calibration. So when we speak about the preview during the process of calibration, so whenever it will happen, you can always log into the website, and you will be able to see the pending measurements. The system is giving you the chance to improve once you do the mistake. Imagine you are calibrating the pipette, and as always, the necessary for such a process is the stability of your head, right? Because you will dispense the liquid in the process, which means according to ISO, and suddenly you've got such a, let's say, kick of your muscles, right? Sometimes it happens that you just touch the vessel, you drop something, the muscles are, tired, and you've got such a kick, let's say. What you can do? Actually nothing, right? You need to repeat the measurement, right? So you destroy the whole process, and we speak here about 8 hours of your calibration, right? Or eventually 1 hour. Our system is giving you the chance that, for example, if I'm calibrating the multi-channel pipette, and I know that I just do the mistake, I can mark one of the measurement as a reject value. Once I do that, the system will repeat, but only one measurement. So it will basically give you the chance to repeat once again the same measurement. The whole process will be fixing, but not all of them, only that one that I reject, and that's it. Nice? I can hear you. Yes? Finally. Oh, 1 hour later there is an action. Okay. So once you see, once I will reject all of them, or a few of them, which is possible, the system will also do the corrections. So that's a very, very nice option. In the settings of the whole website, which means AP12, you've got also the chance to add, as you see here, the data related to the ambient condition module, because when we speak about the ambient condition module, which is calibrated, you will have calibration certificate, and that calibration certificate obviously will have also the corrections, right? Because I'm expecting that all of the sensors, there will be some correction, so you are able to add them, as you see, right? So when your calibration certificate will expire for the ambient condition module, obviously you can recalibrate it in your local accredited laboratory, which will give you again the report, and the report will have corrections for certain points. And you can edit them to the system, and obviously then the whole recalculation will be done automatically. Okay, let's finish right now speaking about the multi-channel pipettes, and then jump to the basic one, which is single-channel pipette, not pipette. I will show you a few other options that we've got in our offer as well. So first of all, when we speak about the accredited laboratory, I can imagine that we would have something like a station for it, right? Station, which means the anti-vibration table, kind of furniture, there is a space for it, and we can fulfill the space by using such a dedicated for the pipette calibration station. So not only device is able to be offered by our colleagues from Intitech, but also such a station. And as you see here, we do have the built-in inside the furniture anti-vibration table. We do have here, it looks like a monitor, which means we do have computer in one of the space, the PC software, the sensors, the balance, either 6 or 5 decimal place, and also the pump here, which will take out the water when necessary and once you fulfill the vessels. Such a station we do have in two different options. Single one with the anti-vibration table only for one balance or for two. So if you're trying to imagine that you are fulfilling the whole range from micro to milliliters, obviously you need to have at least two devices, right? Micro and semi-micro, right? So for those we do have dual station. And here the system will include three different modules. First of all, measuring module, which means just the balance. Environmental module, already mentioned by using that EP12 presentation. And calibration module, which is our software. So that's in details presented here. Examples, obviously, that are used for such a presentation for each module. So first module, which is just the device for weighing. For single channel pipette, we do have semi or micro balances dedicated for such liquids. All of them, like written here, they are following the latest ISO, which means inside that micro balance, which is for single channel pipette, we do have already built in a standard. So the situation will be exactly the same like with the multi-channel one. So you do have here example of dedicated for the single channel pipette. Micro balance in 21 gram capacity, 6 decimal place as a resolution, and as you see here, it is able to operate from 1 microliter. How many? 10 milli, exactly. Which means the vessel for the liquid, it has 11 milliliters. So by using such a chance, the volume, you can just do one measurement, and you need to somehow take out the water from the vessel, and then again you can calibrate continuously the next pipe. Here we do have the example of the microbalance, but this is XA microbalance. The previous one was MYA. MYA means the cylindrical weighing chamber, and XA means cylindrical weighing chamber, but in the construction of semi-microbalance. It means that this is dedicated for the volumes similar to the previous one, but it has the advantage of being automatically open on the top side. So the top side of the cover is automatically opening, like a moving pond or slider, we can say, right? Instead of that one, which is here, manual, right? That you need to use manually open it, and that one also is affecting a little bit the process of calibration. What we've got next, here, we do have to describe in details how looks the whole weighing chamber, or better to say, chamber assembled for the calibration of pipe. So that vessel that we've got here, this is that one that is collecting water. Then we do have something like a holder, and very important part, evaporation trap. My previous colleague was speaking about evaporation trap, and that's a very crucial one because it is helping you to reduce the whole, basically increase or reduce the error, increase the accuracy by improving the moisture inside the weighing anti-draft shield, so the whole weighing chamber, right? Because here we will have the water, we need to wait around 5-6 hours. Once we are fulfilled that, it will evaporate, increase the moisture, and in the same time decrease the process of evaporation, correct? And once you imagine that 1 microliter is quite fast to evaporate, right? When you try to compare it to the drop of the water, how it will be? How big is the volume of the drop of water? Who knows? In microliters, how is the volume of drop of the water? With the regular density 1.2 or 1, let's say, gram. Any idea? How big is the drop of the water? When we do have rain, the water drop is more or less 50 to 80 microliters. Right? So let's imagine even 50 microliters, and we speak about 1 microliter. So this is 1/50 part of drop of the water. And you can easily imagine that once I put the drop of the water on the table, and I see how it looks like, it is just disappearing because it's evaporating. Which means when I just dispense 1/50 part of the drop, it never falls because it evaporates once it is falling, right? right? That's why we do have evaporation threat. If you are using devices without evaporation threat, it's a lot of mistakes. Your measurements are not repeatable, or even you are not able to collect the measurements, because once you dispense 1 microliter, it never falls on the weighing pad because it's vanishing. Correct? That's why such of construction of the weighing chamber for the pipettes calibration, which has built-in evaporation thread, is a very crucial. It's a critical one for every calibration process. Without that, actually, it's a nonsense to calibrate the pipe. Here, you do have the picture of that automatic version for the semi-microbalance, which will open that tongue on the top side. The rest, from the construction point of view, is the same. We do have the vessel for collecting water, we do have evaporation ring here, and that open part will open those automatically by using our sensors. And sensors which are doing the same job like here. So once I move the head above the sensor, as you see that chamber is opening or closing, right? So without touching that, you can swipe the head above the sensor and the chamber will open. And imagine you do have the occupied hand by the pipette, and then you just swipe by using other hand the sensor, it opens, dispense, it closes, and that helps you to increase in the fast way your process and the accuracy. Okay, let's speak right now about the environmental conditions. So the module that I already mentioned when I was explaining AP12, so the sensors. That sensor is measuring temperature, humidity, pressure, air density, and vibrations. It is calibrated. The second one that we are installing in the vessel, which is keeping the water for test, is measuring the temperature of water. And what kind of water we are using for the pipette's calibration? Which one? A little bit louder? Which one? Any water? Distillate or physically clean, right? So that water which has the certificate or at least the purity class according to ISO, because ISO also is written about that, right? So here, when we speak about the table and the sizes of the table, as you see, we do have some dimensions here. They are very ergonomic because this is nothing else like a regular table. We do have the chair with the dedicated for the station, and that's very, very comfortable one for daily activity. The third part is dedicated to the software, and here we do have two options. Either you will just use the balance with the dedicated license, which you will work like AP12. So the system has built-in software. You will use the regular smartphone or any computer. You will connect to the balance, and without any software, you will proceed the calibration. Or you prefer to use the computer, like in the station, and you will have dedicated for the calibration of pipette software, which again will do the job according to ISO, and the procedure will be similar. So you finish with the whole calibration certificate dedicated for such a process. And actually that's it when we speak about the pipette's calibration part. To be able to show you what we can do when I say that you can use any smart device to be able to see the display on the balance, give me a chance to show you that, because besides the presentation, I will try to connect with the balance, exactly that microbalance here, and it will show you how it works when we do have the remote access to such of devices. So just hold on for a second. I need to just connect to the software, just give me a second. I need to connect to the balance. So what I'm doing right now, I'm connecting my computer with the Wi-Fi that the balance is sharing. And every single 5Y series has dedicated so-called hotspot functionality. That's a default built-in application, and that hotspot is giving us the chance to use it in that way that right now I'm connecting the computer with the Wi-Fi shared from the microbalance. Once I do that, I'm able to connect with the balance by using any VNC application, and I will be able to show you on the screen exactly the view of the balance. What it means? It means, Bayu, can I ask you to assist me? If you can just hold it. Take a look. This is the display of the balance. This is something that I just show you by remote connection, and I just use my computer. I can use the smartphone even. So now, when Bayu is playing, did I ask you to do that? I know. You see, the balance is so user-friendly that he's just inviting him to touch, right? So touch, whatever, right? So take a look. Now, whatever he's doing, you see that remotely, right? So we can swipe, for example, just show them, not me, just show to them, please. We can swipe the screen, and here you will see the data, which is environment conditions data. Because once we start the meeting, I choose that the balance will collect the data about the environment every single minute. So we do have here, as you see, the temperature, which is red, the pressure, which is yellow, and the moisture, which is blue one, continuously collected in the room. I'm sweating because of that, and my throat is paying me because of that, and the fluctuations of temperature, right? You see, we do have here the status of the system, ambient conditions. So this is the chart of the ambient condition. This is the chart of the vibrations. As you see, they are quite big one, but nothing happens wrong because still the pictogram shows you green. Let's do the earthquake. And you will see after a while, the balance already changed the results. You will see that that pictogram will change, right? Because we do have some high vibrations. When I touch that, you will see also the indication about the measurements. Readouts, you see that we do have more than 700% of vibrations allowed to be accurate as the balance can be accurate. So after stabilizing again the vibration, as you see, it becomes to be green here. The indication is below 100, so there is no alert. Can you accept it, please? And the chart after a while, once we just collect, because there are some period of displaying the data, we show you very big peak. Can you check that back here? And as you see, the data that is visible right now in front of you also is written in the database of ambient conditions. So you can always report such of data by exporting them directly from the screen. So right now, what is more even funny, when I can say something like that, is that besides that Bayu is going to play with the display, I can do that remotely. Take a look. By using my computer, I can also do the job like Bayu did. So as you see, he's not touching the screen. I'm operating remotely the balance, right? So I can even collect the measurement, as you see. Right now I'm touching the print button, which is here, and I will collect every single time when the data is stable. I'm collecting the measurements. So these are the previous measurements, as you see. This is the functionality of our 5Y series. So remotely, I can manage the measurement from the computer, or I can display whatever or whoever is doing the job here. And when we speak about the AP12 or the single channel solutions or microbalance or semi-microbalance for pipette calibration, you will be also able, like I said, to connect to the balance and display the data directly on the website. And I will show you that as well. Just give me a second. So right now, I will show you how looks that access to the balance. As you see, I'm using just the regular ordinary browser. That's a Chrome, because I like Chrome, so I'm using Chrome. And I did the connection in that way that in the address area, I just add the IP address of the balance. So once I'm connected with my balance, I can use any browser. It can be Safari, it can be Edge, it can be Chrome, it can be whatever you like. Instead of www.whatever you have as an address, sometimes I just add the IP address of my balance, and then as you see, the balance is requiring the verification about the privileges. Because not everybody can see the data, you need to have the access. And you need to log in the same way like we logged in on the screen of the balance. Take a look here. You do have the information about the operator. This is the active user, admin. So when I just go back to my balance, I need to use the same user. While admin has the password or we don't password. So if there's no password, just click login. And then just hold on, just probably the standard one, right? No? That's a tricky. So please remove the password or just change it. You're removing the password? Or you change it, not for you? So let's see what the bio is doing. You can preview that,
Pak
right?
Didi mungkin bisa ke Pak Didi.
1, 2, 3, 4. Okay. So that's our secret password. Don't tell anybody that admin has the password 1, 2, 3, 4. That's a secret. Alright, you sure that's exactly that one?
Udah.
Yes. So once we logged into the balance, as you see, and this is the balance which is not dedicated for the package calibration, it gives you the chance to generate and preview, create database of products, users, and so on. And here we will have also the information about market conditions. So this is exactly the data directly from the balance. And here I can preview about the values which the balance collects during the process of weighing. When I try to change the view for that one which is dedicated for the pipette's calibration, you will see how it looks like, but I will be not able to generate the data because it doesn't have here the solution for pipette's calibration. But still, ambient conditions are exactly the same. Calibrations will be empty because we doesn't have any calibrations. But at least I will show you the how it looks like the database of pipettes. I cannot add the pipette because I'm guessing that the balance has an extension from 21st CFR, right? So let's double check. If the balance is dedicated for the 21st CFR part 11, so the extension module should be on here, exactly this like I said. We are disallowing to edit the databases remotely because it's against the rule. So that's why, as you see here, we are not able to add any new pipette. I can only preview what previously somebody added. And this is how works our remote access to the balance. So this is exactly the functionality which is very unique and very helpful in daily routines in your laboratory. So that's it when we speak about pipette's calibration. If you have any questions to that part, feel free to ask.
May I ask you bahasa? Saya punya pertanyaan bahasa dari Badan Pom. Ya, yang pertama tadi bagaimana proses kalibrasi software dari bagian Mikropipet yang dijalankan itu. Kemudian kalau misalnya perkembangan tadi di kalibrasi mas, itu kan tadi ada measurement and environment module. Nah itu kalibrasinya seperti apa? Kemudian kalau kita melaporkan hasil kalibrasi itu kan nanti tertelusurnya kemana? Ke Radwag atau ke ISO langsung? Kemudian Kalibrasi like reject data. Apakah kita perlu mengambil atau mengetes ulang air yang di apa namanya data yang dicek tadi mas, apakah perlu kita pipet ulang kemudian kita timbang lagi. Kemudian tadi saya lihat diuji dengan coba gitaran ya. Kita misalkan itu sebuah massa gitu. Nah tadi kan nggak balik ya, nggak nol ya, masih sistem. Apakah ada sistem untuk auto zeronya atau kita manual di zeroing atau bagaimana? Karena selama ini yang saya tahu timbangan setelah tes itu dia bisa kembali ke posisi yang
There is for question from Mr. Andri from Indonesian FDA.
Okay.
The first question is how the software validation. The validation of
The software, which one? The dedicated for the pipet's calibration?
Yes, the web editor.
So,
balance, the validation for balance. Validation for balance software.
So I understand the question, but there are always, let's say, two ways of asking such a question. Whenever we do have the contact with FDA, we do have the same question, right? What means validation of software? How to validate the software? For example, Excel. If you have the spreadsheet file which is calculating whatever, like 2 plus 2 means 4, the validation looks like that we need to have something that we, all of us, we accept as a reasonable, reliable device for calculating 2 plus 2, for example, calculating, right? So you just add to the cell 2 plus 2 means 4, and I do have the calculations on the, by using calculator. If they generate the same result, it's okay. You agree? It's validated? Great. If we speak about validation of software, of the balance, I'm guessing that the question is speaking or asking about the validation of the calculations, so the results that we are producing, generating, right? How we can validate that exactly the same way. For every single accredited laboratory, before the era of digitalization, so software, you do have spreadsheet file. I'm guessing that every laboratory which is calibrated pipette, you do have your Excel file, correct? Excel which is already validated. If you are accredited laboratory, you did the validation by using your accredited center, right? They approve it, and then you're just using for calculations. How to validate our software? Exactly the same way. You look at the pipette, like multi-channel 1, 12 channel, 360 measurements. You collect the measurements, you generate the report, you've got the results, and you do have the same results in your Excel file, right? Or manual calculations, once you have such a calculation. If we generate the same results, what we did? Validation. That's okay? This is the only way to validate anything like a software, right? Because the device itself cannot be validated. You can qualify the device, but the software and the calculation, when we speak about calculation, this is not quite the same. You okay with that?
Validation with Radwag.
Pardon?
Yang memvalidasi Radwag kita sendiri.
Who is the person responsible for the validate the software?
Once again.
Who is the person that responsible for validate the software? We is the partner.
In every single area, the user, right? Because if I'm going and I'm the manager of the qualification processes as well, so whenever we do the qualification and there is a question about validation, I can assist you, but actually the final user is validated, right? Because the final user will, in front of auditor, be responsible for the calculations, right? So the operator should validate. We can give you obviously the tools. You can do the verification in front of us or by assisting, being assisted by the technician from our side. But this is the way how all of us will do it, right? Because if there will be, let me say another comment, if there will be other way, you're going to believe me if I will tell you that it's validated by me? Simple question, right? Let's imagine I'm selling the device, I will just transfer that to Intitech will install the balance, and they give you the information like written by email. The system is validated. FDA, we accept it? Come on. Who I am to tell you that it's validated? You need to do it by your own eyes, correct? That's it. Second one?
The second one is
That is okay? Good.
how about the calibration of of the environmental sensors, the humidity, the temperature sensors.
And what about the calibration? Who is calibrating that? So once you order the device, it is coming with a calibration certificate, which we're doing in our third-party company laboratory. So Radwag doesn't calibrate it because we are not accredited for the temperature, humidity, etc. So we are ordering the calibration of that devices by using third laboratory, which is internationally approved. So they do it basically according to system accreditation. And then once you are using the calibration tools, calibrated tools here, you can recalibrate anywhere, right? So if in international you've got some accredited laboratory for the calibration of temperature, humidity, pressure, density calculation that will be done with the need to have calibration, you can do it locally. So recalibration in any accredited laboratory, obviously you can send it back to us, but it will be probably more expensive than in local, right?
Jadi datang itu sudah dapat sertifikat, tertelusur Pak, sama-sama tertelusur, kemudian bisa diverifikasi ulang juga di lokal.
That's okay? Okay.
The third question is about the reject pipetting, how the mechanism to
Once again, how what?
the reject mechanism about the pipetting, how to measure the pipettes.
So imagine we do have the multi-channel pipette, like I said, and we are doing the third series, right? So we do have the first volume, for example, the nominal one. You collect the first measurement, so 12 measurements. The card automatically moves, collect them, goes back. Third series, and then you find out that one of the measurements was bad because of our movement, right? So once you finish the whole volume, because the question appears once you finish the volume. So after 10 series of measurement, the balance will ask you, there is something to correct or not. If not, it will go to the next volume. If yes, you mark the point, and the balance will ask you, okay, dispense 1 second 12 measurements, so means you just take the water, dispense that, then the card goes not one by one, it goes exactly to the point which is rejected, right? So if it was fifth vessel, so the fifth tube, it will go to the fifth one, we'll just collect one measurement, go back. So very fast, very reliable, and then again we continue with the next volumes. Exactly that measurement, right? If you decide that all of the vessels, because you hit actually 12 of them, you can just mark all of them, then it will repeat all of them. If you are doing single channel one and you just know that on the fifth position there is something wrong, just mark fifth, it goes to the fifth, collect the measurement, even if it dispenses all of them, right? It will only measure the one volume. That's okay? Good?
The last one is about that previously we test the salt sensors and the measurement not go back to zero. He is asking why not go back to zero and how to make zero. Again, is it auto zero feature or should be manually zero in the balance?
Both actually are proper one. So let me show you once again how to use the balance, right? So right now we do have unknown status of the balance, correct? We do have something like a 24 micrograms mistake error, I don't know. So whenever we do the job, I try to lift the balance right now. As you see, this changes the result, right? Probably it won't go back to the 24. You see the balance is even smarter because we do have automatic leveling system. So it recognizes that there is no level. As you see, it doesn't go back. Somehow by accident we are closed, but still it doesn't go back because this is not anti-vibration table, it's not laboratory, right? Even if we are doing exactly only something like that, there is a soft material, so the angle of that probably will change the result, right? But let's imagine that we go to the second part of the question. How to zero it? All of them, the balances, they do have, can you hold it please? They do have the zero enter button, right? So zero means we are zeroing that, again, level. We just zero it. And then, accordingly to the metrology, we do have also up to zero section, right? So this is the pictogram which shows you I'm stable, ready to read. So the measurement is ready to be accepted by touching the pin button, and that means we are in the zone of auto zero. And these are 3 digits, right? Metrologically 3 digits, because it's written by standard. This is not our idea. We speak about EN45501. So the standard which is responsible for legal metrology. And that, this is why right now we do have zero. And the auto zero is a very strong one. This is the system, a lot of filters which are keeping very strong zero. To go out of the zero zone, the balance will require a little bit, not like just gently touching, right? It requires some major change of the angle, or I can touch the vehicle maybe. And then we see, as you see, the chamber is open, so we see maybe eventually the balance will go back to the zero. But again, this is not double as we do have crazy air conditioning, the temperature is rising, the chamber is open, but still it is trying to manage the stability, right? It's not returning to zero, or slowly, as you see, it's going back to zero, because first of all, the environment around, second of all, table, third of all, which is most important in the whole story, the balance was switched on how many hours? 5 hours ago? 3 hours ago? Which means the balance is warming up. Please don't forget that for any kind of weighing instrument, so-called balance, we need to always wait until we warm up the device, right? So once I plug in the cable, I switch it on basically. Who is playing with me? After I switch on the balance, I do have the certain time to wait till the measurements will be stable. And that time is longer once we do have more digits on display. When we do have microbalance, and microbalance means 6 decimal place here, the balance after switching on require at least 20-24 hours to get stability of the temperature, and then repeatedly continues the measurements. So that's why it is fluctuating. That's why we do have not returning to zero option, because of the warming up time, besides the whole environment. Okay? That's good? More explanation, or is enough? Is enough, okay. My pleasure. What kind of questions we've got more? Any more?
Sebelumnya perkenalkan saya Pandi dari PT Analisis Sempurna. Izin bertanya, tadi kan yang intervention Mikropipet yang wiki itu dia ada pump buat ngeluarin airnya ya. Nah itu apakah ada kemungkinan ketika kita menggunakan dia nggak berfungsi, atau ada tombol buat kita memfungsikan pumpnya tersebut, atau dia kan katanya tadi otomatis juga. Oh, ya apakah ada kemungkinan dia nggak berfungsi atau mampet, ada peringatannya gitu? Terima kasih.
So once we connect the pump, here there will be a pictogram that is connected. So if there is no communication, there is no symbol that the pump is connected. That's the answer for the second part, right? It is working manually. So we do have, like I said, there's like a tube which has four small tubes to 4x4. Just take the water from 4 vessels, 4 vessels, 4 vessels, or single one. So there's like 1 by 1, right? And there are buttons. You just switch it on, it takes the water, you switch it off, and that's it, right? But if it's not connected, you will see on display, right? Because the pictogram there is on.
Is there any warning at the vessel if the vessel already filled with water?
That's a good question. So once we are using the multi-channel pipette, we are calculating how much we do have already collected water in the tubes. So whenever we start, the first step is to move the card and check that it's movable, so there is no mechanical issues. Second one will be tear the whole vessel, so we are basically doing the zero level of the measurement. how much water we've got in the vessel. So if we are in the process and there is a need of taking water, it will show you on display, I need to remove the water from vessels. If we start the process and we know that there is already collected water, and the whole measurement doesn't finish with the, there is no space, it doesn't allow you to start. It will tell you before you start, remove the water because there is no space. So it's safe in that way that the dummy operator will manage that, right? Any more questions?
Yeah, thank you. Okay, sir, my name is Hussein from Psikovido in the laboratory. And then I want to ask you maybe because I want to tell that I have a microbalance in my laboratory, but sometimes I used to calibrate the Mikropipet OVA. And then I have the new temperature, good temperature, and then humidity is good, vibration is good because I have the table is okay. By student table, it's okay. Settled in Massa laboratory. But sometimes I have a problem when we use calibrate the micropipet about the repeat is fluctuation and then the result. I know I want to ask you what is the problem with the micropipet? Maybe the part of micropipet is often affect the repeatability and the result. Maybe the pump, maybe the piston, maybe the cylinder of the micropipet because the result is not good. Yeah, repeatability is all fluctuation. The balance is okay, no problem. Temperature is okay, humidity okay, and the stable vibration is okay. But micropipet is not good. The result. Thank you.
That's a good question. The balance, it has evaporation trap.
Pardon?
The balance, it has evaporation trap.
Yes, I have.
You'd have it. It's full feed all the time. So you've got water always inside the evaporation trap.
Yeah, I have the evaporation trap in balance.
Always with water?
Yes.
Okay, and then the operator is exactly the same?
Yes.
All the time? The balance doesn't produce errors when you do the calibration with a higher volume?
No.
Only with a small volume?
Yes, yes.
And the pipet, you try to adjust mechanically, so change the O-ring, change the piston.
Yes, mechanically.
And it is
Mikropipet, yes.
and then you recheck and it's better?
I don't know, yeah, but my friend to calibrate this every day, yeah, because I have order with my customer micropipet. Sometimes it's good, sometimes it's not a problem, yeah, with the pipet.
So in my opinion, the troubleshooting should be like that. But first you check the balance, right?
Okay.
But check the balance by using Massa, obviously,
Mhm.
that it's repeatable considering the device itself. The calibration of pipette is not related to repeatability of the balance. It is related to the differential measurements, right?
Okay.
So it's good to check first of all that the balance is okay. That's the first step. Second one is to check that the pipette itself is okay. So if you do have the pipette which is calibrated somehow on the other laboratory and you've got the calibration certificate, so somebody check it, use that pipette to test the balance, right? If you're saying that the evaporation trap is always full filled with water, so we do have always the high moisture inside the chamber, so there shouldn't be any issue with the evaporation, because evaporation is, in my opinion, the issue here, right? If it is okay, then the next step is how the person is taking the measurements, how we are, so basically the handling of the measurements is important here. Many times, I will try to show you that. Can I have something like a empty glass? Like a not used empty glass? Not really. It just give me some. Oh, there is some not used. Okay. Thank you. So with pipette calibration, the handling sometimes it's written in the ISO, but handling sometimes people they're doing it the wrong way. So when we do have the pipette, right, and they basically follow the straight, not the opposite, I mean not the reverse, but straight option. So we just basically go to the first one, right? They're doing like that, once they take the water from the vessel, they just collect the water and take immediately the pipettes out. You can observe that sometimes when you just choose milliliters, there will be a part of drop. If you do have microliters, operator doesn't see that at the end we do have a drop of water. That's why in our facility, the handling is like that we are taking the water on the edge, out, and then we always do like that. Always. When we just take the water to dispense for the calibration, right? So the measurement always is like that. That helps us to remove the rest of the water on the tip of the tip. If you know what I mean. If you speak about milliliters, you see that just do the experiment. Take the milliliter and you will see the drop here. If you have microliters, you don't see that. But there is something, right? If we speak about such a mistake, and like I said, the balance is okay. You've got the evaporation, which is good. The environment is okay. What we can do is just the water somewhere we are missing, or we do have some more water. And I'm guessing this is the end of the tip. So the tip of the tip. So that's why we are taking up the water on the edge, like we dispense, because we dispense also on the edge, right? We are not dispensing in the air, right? According to ISO. So we're taking out, and our colleagues, they do like that, the job, just to remove the water from the tip. And that helps also a lot. Try it, maybe that's the reason. The other, it's hard to say.
After you get, and then I will pointing timer to tip and then I will give you a 30 second and then pull out. And then see this.
30 seconds, you're waiting 30 seconds?
Yes, waiting.
Wrong. Just ISO itself, if you just read the ISO, it's written how much time you need to have it. It's written that it's not good, because once you're waiting 30 seconds, there's also evaporation pending. There is, because you do have that 30 seconds in the environment, which has a huge difference of the moisture here and inside that glass. That's why we do have evaporation thread. To do it immediately here. So you've got there's a certain dip of the end of the tip under the surface. There's a certain time that you need to take it and dispense, because if you're waiting, probably that's the reason, even more than just the movement, right? So 30 seconds definitely no. It's much too much. Pleasure. What else? Any more questions?
Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, saya Ali dari Lab Kalibrasi Massa. Yang ingin saya tanyakan adalah mengenai software yang dipaparkan. Kan kalau di ISO 8655/2002 ini terbaru kan ya Mas, kalau nggak salah. Terus kalaupun nanti in the future we have a renewal version, itu apakah kita dapat updatean terbaru mengenai softwarenya, atau kita harus membeli lagi timbangan yang baru dengan software terbarunya?
So right now the software is built based on the ISO 8655 revision 2020. If there is new version of the ISO and the balance need to be upgraded, is it required to just update the software, or we need to buy the balance?
But they're using already the balance from Radwag.
Yes.
So the update of software should be.
Ditambah lagi, saya nambahin pertanyaan dari yang Bepo mungkin. Kan validasi software itu mengenai tentang sumber-sumber ketidakpastian kalau dalam Mikropipet. Apakah Radwag ini mengeluarkan hasilnya sudah berdasarkan sumber-sumber ketidakpastian yang ada dalam ISO 8655, atau hasilnya perlu kita validasi untuk lanjutannya.
Mungkin bisa dielaborate lebih Pak, maksudnya gimana?
Kan biasanya sumber-sumber ketidakpastian itu kan bertambah tuh Mas. Misalnya kalau yang sebelumnya kita tidak ada kesalahan operator atau mengenai tipnya, terus macam-macam lah gitu. Apakah di software ini sudah ditambahkan tentang yang terbaru itu?
So the uncertainty of the balance is not only based on the balance itself, but from the operator, from the environmental maybe. Is it already included at the balance, or we need separate validation to?
So when you speak about calibration, uncertainty is never related to the device. Uncertainty is something that you are calculating after installation, right? Because uncertainty is the other way saying is how much we doesn't know or how much we don't know about the result. That's uncertainty, right? So whenever you install the balance, you need to calculate the budget of uncertainty, right? Which includes environment, the handling of operator, the device, the whole calibrations, which means the uncertainty we do have in the calibration of the devices for measurements, all together gives you the budget, right? So that's why we will speak about CNC, right? So CNC actually is your mark on the market. I'm very good because all of the procedures, devices that I'm using, they do have lower uncertainty. If I do have the chance to choose in between of different accredited laboratories, I will choose the best one by CMC because that gives you the mark. I'm better than the other, right? But this is not related to the device only. And the device doesn't give you the information about uncertainty because that balance will be better in my facility, probably worse in your facility. Why? Because in my facility, I do have crazy stable environment. And if you have exactly the same, you can expect the same uncertainty. But I'm guessing your environment will be a little bit worse than in our quality department, correct? So that's why you will have worse uncertainty by using the same device. You following me? And speaking about the update, the question is also what kind of version of balance we have. Because if we have 4Y series, it won't be able. We speak about 5Y series, sure.
Yes, they are connected by 5Y next year.
So yeah, you will just
maybe mau nambahin, mungkin CMC-nya mau dimasukin ke timbangannya gitu Pak, buat perhitungan nanti di sertifikatnya.
Kalau yang sebelumnya kan saya software itu hanya mengeluarkan sampai di titik koreksi dan sampai koreksi saja. Dan kita tidak kepastian dari CNC-nya itu kita tambah sini. Saya kira dari verifikasi sudah semuanya sama sekali sama.
Bapak Ibu mungkin ada lagi yang ingin bertanya terkait kalibrasi mikropipet. I think for the micropipet, maybe we can we have like 10 or 15 minutes for us.
So give me a moment. I will change the presentation. So the last one for today, that will be the short overview of the mass comparators. And here you will have general overview, very the same like Cesar was showing in the presentation of Radwag, when he basically tried to overview shortly the mass comparator offer. I added in meantime only a few more information. So first of all, when we speak about mass comparators, for those who doesn't know what it is, this is the special kind of balance which is dedicated for the calibration of mass standards. Other way saying weights. So we need to have the device which are working in the, like here for example, in the very, very high resolution, considering the weight opportunity and high masses. Imagine that we do have 10 kilograms with such a resolution as a regular balance, right? It will be very, very nice. But we're not able to do it. That's why comparators are dedicated only for mass calibration. So they are weighing in the accurate way, but very narrow area when we speak about the mass. In our offer, when we speak about the mass comparators, we do have, first of all, the whole manual set, beginning from
Terlihat
7
sepele,
displays,
namun bisa buat
finishing with
poster.
the high resolution platforms, platforms comparators, up to 2,000 kilograms. When we speak about manual offer, then we do have automatic mass comparators. So non-manual, automatic one, which starts by using that UMA mass comparators also with 7 decimal place, and finished with the AK4 and AK2 for the high capacity, as you see here, 10 and 50 kilograms options as a automatic. Here we do have also that very unique one that Cesar was explaining, which is first and only one mass comparator, which is measuring with how many decimal place? How many? 4, 3, 7. How many digits we got here? How many zeros? 8. That's the first and only one on the planet Earth device which has nano resolution, which means 8 decimal place, right? Our competitors finish only with 6 or 7. Here we do have 8, and these are automatic mass comparators. Then we do have the robotic mass comparators, and this is the presentation about them. And here we do have also a few options depending from the mass standards and as well from the resolution. So we start from the robotic mass comparator, which is dedicated for the masses like with the maximum capacity 5 and 10 grams. So we are able to calibrate the ranges from 0.05 milligram up to 10 grams with 7 decimal place. Robotic mass comparator, like Cesar was explaining, this is the device which is using the robotic arm and is measuring the objects or masses by using automatic mass comparator. So this is a very unique, available only in Radwag offer, the combination of automatic mass comparator which is working together with robotic system. The competitors doesn't have it, and we are proud to show you that the RMC with a magazine up to 120 position is able to do the job as a combination of the automatic and robotic systems. That combination, you will see later as well, I will just say a few words before, the combination gives us the unbelievable repeatability. So we are very, very good because of such of systems comparing to competitors. Here you do have the bigger brother of RMCN, the RMC system, which is operating up to kilogram as you see. So we do have two versions, 110 and 1000 grams. And that machine is able to operate with 100 positions. So we are able to use it also in the same way. This is a combination of robotic arm with automatic mass comparator for special solutions like mass comparisons. All of them, the robotic mass comparators, they do have the fully automatic change of the, we call that internal ballasts or internal weights, to be able to change the, what? The range of operation, right? So as you see, without the need of using operator, the automatic system will adapt the internal ballasts to be able to change the range for the comparisons. All of them, they do have the internal adjustment, which is very useful considering the robotic systems, because you don't need to interrupt the process of calibration, do the external adjustment, like competitors offer. You basically use the machine as standard balance because it has built-in internal adjustment. The advantage of the combination, we call that robotic robot, so the combination of the robotic arm with the automatic